Okay, now we're going to look at that same page. Let's see, make sure you know where we are. On page 3, where we inserted the values to figure out what the y values were. But another way to figure out slope, if you remember, is we do the constant rate of change. So remember, you put the carets here, and you go 2 minus 6 equals negative 4. 6 minus 4 equals negative 2. And then on this side, you go negative 3 minus 3 equals negative 6. I don't know if you can even see this very well. I'm going to try to make it bigger. And then 3 minus 0 is 3. So it's the change over y equals the change over x. So equals negative 4 over negative 6. Then it's 2 over 3. Now, are these equal? Well, if you take the negative 4 over 6 and you divide the numerator and denominator by 2, you get negative 2 over negative 3. And because they're two negatives, it becomes a positive. So yes, it becomes 2 over 3 is the slope. And it is a constant rate of change because they're both the same. And if you graph it, it's still 2 over 3. Okay? Now, if we look at the next one, it's negative 5x over 7, and we said the slope was negative 5 over 2, just like we said this one was 2, 3. Okay? So when we do the negative 5 over 2, we're going to go negative 3. Again, we put the carets here. Negative 3 minus 2 equals negative 5. 2 minus 7 is negative 5. 4, we have the carets here. 4 minus 2 is 2, and 2 minus 0 is 2. So the change over y, the change over x, it's negative 5 over 2, and it's negative 5 over 2. And they're both the same, and when we check it here, we go down 5, and we go over 2. And is it a constant rate of change? Yes, it is. So I just wanted you to see both parts. Okay, so we're done with this part up here. So then we're going to go to the bottom of page 3, and it is asking us which of the lines in exercise 6 and 7 is steeper. Now, if we look at the slope, which we set up here was 2/3 for number 6, and negative 5 over 2 for number 7, if we take the absolute value, remember that's the distance from 0 for both of them, so it's negative 2/3, so absolute value is 2/3, or if you divide 2 by 3, you get 0.66. If you take negative 5 over 2, the absolute value is 5 over 2. When you divide 5 divided by 2, you get 2.5. So here we know absolute value of number 7 is greater, therefore has a steeper slope. So the absolute value of 2.5 is greater than the absolute value of 0.66. Okay? And then we are going to go to page 4, and we're going to calculate slope using this formula. Okay? So again, I like to write the formula down. It keeps us where we need to be. I label these. And I think I'm just going to go ahead and label all 4 of them. x1, y1, x2, y2, x1, y1, x2, y2, x1, y1, x2, y2. And I'm going to put the formulas here so we're all set. And if you want to go ahead and plug them in ahead while I'm doing this, go and see if you can do it. Okay? Okay, so here, the first one, we are going to do, this is supposed to be y2. So y2 is 11 minus 2, and y2 is negative 2 minus 1, which equals 9 over negative 3. And if you were to simplify this, if you divided the 9 by 3, you'd get 3. And if you divide -1 by 3, you'd get -1. So this would be simplified. Okay. Now the next one we can do is y2 is 10, y1 is 5, x2 is 2, x1 is 0. So 10 minus 5 is 5, and 2 minus 0 is 0. 2 minus 0 is 2, excuse me. Jeez. This would be the slope. Okay? So here, we're going to go y2 is -5 minus 1 for y1. x2 is 1, and we're going to, x1 is 1, so we're going to get -6 over 0. And this would be undefined. And I want you to note that both the x-coordinates are the same. Okay? So if you look at this, both the x-coordinates are the same. And that will give you an undefined slope. Okay? Now the next one, like see, you can see the whole page. So the next one we're going to do is y2 is 1, y2 is 1, y1 is 1. Then we're going to do 5 x2 minus -8. Now remember, you have two negatives together, they're positive. So 1 minus 1 is 0, and 5 plus 8 is 13. Now this is a 0 slope. Okay? And I want you to note both, all right, note both y coordinates are the same. Okay? So you notice the y's are both 1. Okay? And that would be 0. Now, if we go back here, we know there's a negative number here, so we know this is a negative slope. And we know that this is positive, so this is a positive slope. Okay? Just so that we're on the same page. Now, the next one, I color-coded. And I'm going to let you take a few minutes to really look this over. But if you look at A, which is blue, it goes up 5 and over 8. So the slope is 5 over 8. If you look at B, it goes down 11, which is -11, and it goes over 5. Then if you look at C, it goes down 19 and over 5. So going down is negative and going to the left is negative. But remember, when you have two negatives, you get a positive. All right? And then D, you're going to go down 6, and you're going to go over 13. Okay? And then E is just up and down. So that is undefined. And just like we said, when it's undefined, both the x-coordinates are the same. Okay? So I'm going to let you take a few minutes to look at that. And while you're doing that, I'm just going to finish up like this one, 5 over 8. They also want you to say if the line is steep or not so steep. So it's not so steep, 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 not so steep, and there's not a steepness here. So the way I look at it, whether it's going to be steep or not, is if the number on top, the numerator, is the same or greater, like these, notice these are higher than the denominator, you tend to have a steeper slope. When it's less than the denominator, it tends to be not so steep. Okay? And I'm just going to have you look at this, take your notes. You can pause it. And if you want to go get some markers or colored pencils to help you, remember you can go back and forth. And if you have any questions, please make sure you let us know. Thanks for listening.